Today we're going to talk about parallelograms. And now an important detail to know right off the start is that the whole idea of these shapes is right in the name. You can see parallel, and that's what these shapes are all about, quite frankly. So let's just talk about some properties of the parallelogram, as that will kind of help you understand more what we're working with here. So to start with, the opposite sides share the same side length. So we're going to make an example parallelogram here. Let's say this side is 5 and this side is 7. Okay? That means additionally, this side is 7 and this side is 5. So that's an important detail that needs to be true for a parallelogram. Another detail that needs to be true is that the opposite sides are parallel, and that's what I was talking about with the name, that they're parallelograms. So we can express that with these arrows right here. Just match up the same arrows, 2 arrows, 2 arrows, that means those are parallel. 1 arrow, that means that's parallel. And then yes, opposite sides do all share the same side length. So we got 5, 5, and 7, 7. Another important detail, which is like the third piece of the puzzle here, is that the corresponding angles do share the same angle. So we won't assign any here, but I did want to point that out as an important detail of the parallelogram. So to start with, that's a lot to look at, but just know that in the name you got the main feature, which is that opposite sides are parallel, and that causes the opposite sides also be the same length, and then that also causes the opposite angles to be the same as well. So we got a lot going on here, but the last detail I did want to mention is that you will probably have a height measurement in this, which just goes from one of these corners all the way down to the bottom. So this is a lot to look at initially, but all you need to know about parallelograms. So let's go over it. Opposite sides are not only parallel, but they share the same side length. Corresponding diagonal angles here are the same. And then you'll also be given a height measurement in one of these cases. So let's say for this one, the height, that looks like about 4 compared to the other sides. We're going to first talk about perimeter here. So when looking at perimeter, same as all of our shapes, we know that perimeter is the sum of all the sides. So in this we have 5 plus 5 plus 7 plus 7, which is 24. I'm going to say units. That's a little messy, but yeah, units right there. And now we can look at area. And looking at a shape like this, especially when you haven't dealt with area of many shapes, might be confusing. You're looking like, okay, we got triangles going on here. We got slanted edges. How do I find the area, right? It's actually not that difficult. Luckily, this triangle, if you put into that blank space right here, about fits the same. It actually does fit the same. And that's why we can just do base times height. And now you might not know what to pick as base, and that's okay. Let's look at this. So we know our height given right here is 4. That's always going to be given you mostly, or you might have to solve if you have to use the Pythagorean theorem for the triangle. But in this case, it was actually given us. So we can just write 4 in, and we'll just remind ourselves that's the height. And now we need the base. So the base, you can kind of think of like a square or a rectangle. We're going to multiply one side by the other that goes throughout the shape. So here we have a base of 7. So we multiply this base down here throughout the height. We're going to be filling in the shape. And we're going to be finding this area on the inside when we multiply it. And now I know it's confusing because there's those triangles involved, but just know that this area basically gets put over to here and it turns into one big rectangle. So that's kind of the idea when we're looking at parallelograms, just knowing how those general shapes end up working together. But you don't need to understand that necessarily. You just need to understand how to find the base and what height to use when you have that base. So 7 times 4, we have a base of 7 times a height of 4 is 28. Then we can say units, however you want to measure it, squared, because we're working in 2 dimensions because we're multiplying these sides. So that's all you need to know when it comes to properties of the parallelogram. Now let's look at some examples here. So I'm going to provide you guys with this side length of 3, this side length of 2, then a height of 2.5. Now I want you guys to take a second here and try to find the perimeter, and then also try to find the area. So you can pause the video if you want, otherwise I will get going on this. So you might think we don't have all the sides. How do we find the perimeter? That's a good question. We know that one of the properties of parallelograms is that the opposite sides are the same. So we can just fill in these sides. 3 plus 3 plus 2 plus 2. So that's 6 plus 4. It's 10 units long. And now when it comes to area, we know we're given a height of 2.5. And since we're trying to find the area throughout it, we know that we have to multiply it alongside the shape here. So let's have 2.5 times 2. And that's going to end up being 5 units squared. So I hope you guys can see from that example alone why it's important to understand the properties of a parallelogram, as it can help you fill in a lot of blanks that you're not given on purpose probably on your test, just so you can understand how the whole shape relates to itself. So let's look at another problem here. Let's say we have a parallelogram, height given 2, 4, and then we got 2.5 on these sides over here. So again, you can take a second, pause the video if you want to try, but I will walk it through again. So we know since parallelograms we're working with here, the opposite sides are the same side length. So we can do 2.5 plus 2.5, and then plus 4 plus 4. 2.5 plus 2.5 is 5 plus 4, 9 plus 4, 13. And then we would have units as well, because that is a side length that we're talking about here. Now area, we can see that we're given a height of 2 to start with, times a base of 4, which would be 8 units. Then it's squared because we're working in 2 dimensionals, because we're multiplying side lengths to find the area within the shape. And now I did want to talk about one more important detail revolving the parallelogram that we didn't necessarily mention. So say you have sides, well, lines that go from corner to corner on the inside of the shape like this. Now you wouldn't see this in like real math problems most likely, unless you're really getting into geometry. But there is an important detail that we have to look at here. So when you have this case where these lines intersect like that, let's look here. We know that where they intersect is actually the midpoint. So the midpoint means that when a line gets separated at that intersection, that the two sides that it leaves behind are equal length. So obviously, I mean, you can eyeball it and understand that this line is longer than that line, so they're going to have separate lengths. It doesn't necessarily matter what. Let's just assign some values here. Let's say this one is 3, this line right here. And this one is 6. Definitely not, that's not up to scale, but let's just say it is. So since we know this one is 6, this one is 3, I'm talking about these lines right here. We know that this one is also 6, this one is also 3. So that's just another detail that you can keep in mind when it comes to parallelograms. Your teacher might ask you about that on a quiz. But what I would really focus on when it comes to knowing this shape is all the detail here. So we'll go over it. I can actually write this out. It might be good to screenshot. So opposite sides. We got, let's see, same length and parallel. So that's an important detail. And that's area equals base times height. And that again comes from this triangle going over into this empty space and creating a rectangle by the end of it. So when you're working with parallelograms, you'll typically see this slanted shape, and they kind of do that to throw you off a little bit to help you understand the idea behind it. But in reality, we can see things like a rhombus, a square, and a rectangle all count as parallelograms. They're all quadrilaterals that meet the same exact properties. However, this is the shape that you're going to want to understand to actually be able to succeed on quizzes and to have a deeper understanding of geometry and how everything relates to each other. So beyond that, there isn't necessarily anything more you need to know about parallelograms. However, I would go over this video again because it can be confusing the first time around. If you guys have any comments, questions, or you just want to talk about it, you you can leave a comment in the chat, and I'll make sure to go over those concerns with you. Otherwise, I hope all is going well with geometry, as it can be confusing around the first time. Thank you. Take care.